There's this graph that sometimes people use. It's called a box and whisker plot, and you don't really hear about it that much because it has really one specific goal. And if you're not trying to achieve that goal, then it's not really worth thinking about. And I'll explain what that goal is in a moment. A box and whisker plot displays a data set along a number line using medians. And quartiles are dividing the data set into 4 equal parts. If you think of quarter, quart, there's 4 quarts in a gallon, there's 4 quarters in a dollar. So quartiles separate the data into 4 parts. So here's what the box and whisker plot's all about. So you've got this list of data, and what you want to find out if you're doing a box and whisker plot is, where do the majority of people land? So this is the box and these are the whiskers, as you can see in the picture, and this is where the middle 50% of the people are. So this is where that middle section is. We know that there are going to be a couple people down below, and we know that there are going to be a couple people above. This will be 25% and 25%. But if you want to know if you're, like, let's say we're talking test scores, right? You got a test score of an 82. Was that a good score or a bad score? Was that like what most people got, or was that not like what most people got? So what you want to do is you want to say, this is where the middle section of the group is, and this is where the top 25% are, this is where the bottom 25% are, and unless you're trying to represent that sort of data, you're not going to use a box and whisker plot. There are 5 things that you use to make a box and whisker plot, and I'll explain what those are as we go through, but sometimes you'll hear it referred to as the 5-number summary. So let's make one and let's figure out what these 5 numbers really are. So we've got this list, and it looks like they are ages of the members of the U.S. women's wheelchair basketball team. So I've got steps. First, we're going to put the data in order and find the median and the quartiles. So pause the video and just make me a row of the data, and you can find the median. I'll help you find the quartiles because we've never done those before. All right, so you can say I put the data in order, and I also found the median. So what you do now is, looking at this section, which is the bottom half of the data, forgetting about that median because it's not really in the group. So that's bottom half of the data. Where is the median of this group? So just look at the blue section. Where is the median of this group? And the median of this group is here at 23. So now look at this blue group. Where is that median? The median of the top half. That median is here at 29. What the blue values represent are what are called the quartiles. This is representing quartile 1, and this is representing quartile 3. So now I ask you, where do you think quartile 2 is? Good guess. It's here at the median. This represents that second quartile. So those are the 3 quartiles. Quartile 1 is 23, which is the median of the bottom section, and quartile 3 is the median of the top section. And obviously quartile 2 is the median of everybody. We also want to identify the smallest number and the largest number because that's where we're going to stop our whiskers. So I'm going to circle. This is the smallest number. This is the largest number. And now you see there are 5 numbers that are identified as important values. Here's 1, 2, 3, 4, 5. That's my 5-number summary. Those are the things that I'm going to use. So now, according to my steps, I draw an equally spaced number line to include the 5-number summary. So I need to have a number line, And I'm going to make sure that I can fit 18 all the way through 30 equally spaced. So 18, I could probably go by twos. I probably could have spaced that a little wider because now I still have a lot of room. But equally spaced, and obviously if you have graph paper handy, it's probably best for you to use graph paper because then you can guarantee that it's equally spaced. But you can always draw it on line paper or white paper. It's not that serious. So now that we have our 5-number summary, you want to put dots at your 5 numbers. So there's my 2 green points at 18 and 30. I've got my median at 25. And my quartiles are at 23 and 29. And I used multiple colors just because they matched the things I had identified. You would never use like 5 colors to make a box and whisker plot. That's just ridiculous. So draw a box using the quartiles. So I'm going to draw a box like this around the blue dots representing the quartiles. I'm going to draw a line through the median just like this. And then I'm going to connect my whiskers to the box. This is the box and whisker plot that represents the data that I had. So what this shows me is that 50% of the people are here, 25% are here, 25% are here. Now, they're not equally spaced because they're all distributed differently. So 25% of the people are between 23 and 25. That's a lot of people. You know, if you think about it, a quarter of the people are between 23 and 25. A quarter of the people are between 18 and 23. That's a bigger spread. So it tells you how far apart the values are. Maybe there's an outlier and you want to get rid of it. But obviously there's a lot of people between 23 and 25 because for this little tiny box to represent 25% and for this long whisker to represent 25% and for this box to represent 25%, etc., then they represent the same amount of people, but their spreads are different. One other thing that we can do to describe the box and whisker plot is we can talk about how it's skewed. So in a moment, we're going to get specific with the type of skews, but as a precursor to that, this would be considered skewed left. And the reason that it's skewed left is because the longest whisker, the whiskers are not equally spaced, or equal length, and the longest whisker is here on the left-hand side. There's this other type of dispersion, and it's called the interquartile range, and obviously it has to do with the quartiles. So, and being a range, right, you subtract the largest minus the smallest. So it's the difference between the largest and the smallest quartile, which is the Q1 and the Q3. And it represents the range of the middle section. So, find and interpret the range of the data. So we've got this box and whisker plot representing the lengths of songs played by a rock band at a concert. So we've got 300 seconds all the way down to 160 seconds. So this is a really long song. This is a really short song. This is where half of the songs that they play are. What's the range? So obviously the general range is 300 minus 160. So that's 140. The song lengths vary by at most 140 seconds. Okay, describe the distribution. So I want to know what does this bottom whisker represent? 25% is representing the bottom whisker. That's between 160 and 220 seconds. Half of the people, or I'm sorry, half of the songs is between 220 and 280 seconds. And the top 25, the longest 25, is between 280 and 300 seconds. Finding the interquartile range. So that's the Q3 minus Q1. So that would be 280 minus 220, which is 60. So the middle 50% of the songs vary by at most 60 seconds in length. There is a reason to find the interquartile range as you do more advanced things with box and whisker plot. There's a way to determine if something is in fact an outlier. Remember, an outlier would be something that doesn't go with the rest of the data. So if everyone got in the 70s on a test and one kid got a 90, there's a way to mathematically determine whether that is around the same or whether that would be different. For example, if everyone got in the 70s and 80s and one person got in the 90s, is that necessarily so far away from everyone else, or is that part of everyone else's group? Would that data be excluded or would it be included? But we don't look at that in this lesson. So there are different types of ways that you can have shaped distributions. You can have things that are skewed left, where the left whisker is longer and most of the data is on the right. You can have a very symmetrical, or you could have it skewed to the right, where the right whisker is longer and most of the data is on the left. So we've got this thing called a double box and whisker plot, and it's just taking two box and whisker plots, putting them on the same number line so you can compare them. It's like when you want to compare two lines or two graphs, we always put them on the same grid so it's easier to look at them. So the first thing that we have to do is identify the shape of each distribution. So let's say your class would be skewed left. And I'm going to get snazzy with my colors to match it with the picture. The friends class is symmetrical. Now I have to determine which test scores are more spread out. So if you look at the box and whisker plots, your friend's class has a wider range. That goes from 60 all the way to 100, whereas your class goes from maybe like 68 to 100. So the answer is the friend's class is more spread out. And what might happen, who knows why, because we don't have the list of numbers, but this could be where in the friends class, everyone got, there were a whole bunch of grades and they were just spread out. And in your class, you might have the most of the people scoring here, and then there's maybe one or two people all the way down here, and that's why the whisker has to go all the way out to that lowest point. But let's say that there's just one or two kids over here, and then when you pull those out as an outlier, it's more, this is where the whisker is. And that might be more symmetrical as well, even though it'll be shifted up. So it doesn't really tell you necessarily a lot of information, but you get to see where the bulk of the class is. If you have any questions, write them down and ask me when you come to class.